Here's what I plan to do today. What I plan to do today is talk a little bit more about database design and then have you work through a database design exercise as a group. And then depending on the time, either we'll discuss it as a group or we will talk about it next time, depending on how long it goes. We should be able to work through the example and discuss it this time. All right. We left off last time discussing foreign keys. And we said that foreign keys work something like this. If you had a student table, let's say, that is likely going to have a primary key of student ID and might have the first name, last name of the student. And then we have a faculty table that is going to have a faculty ID, first name, last name, and so on, that there is liable to be a relationship about those, between those entities. Namely, there might be that a student has a faculty advisor. And that relationship is accomplished by what's called a foreign key. In other words, the student will have an attribute that points to the primary key of the faculty member. And that's the only piece of information that you're going to ever store in another table, is you may store the primary key of another entity, but you won't store any other attribute of that entity. So, for example, if one of the attributes in the faculty table was the faculty member's office, we're not going to store in the student table the faculty ID and the office of the faculty member. That's redundant data. All right? If the faculty member moves offices, you would have to change it both for that faculty member and for each of the students that that faculty member advises. And that's not good. If something changes, you should only update it in one place. Your database should be designed such that you only need to change it in one place. Therefore, that wouldn't be acceptable to have office there. We would only have the faculty ID. If we ever wanted the office, we could use the faculty ID in the student table to look up the faculty member in the faculty table and find their office that way. All right? This is a foreign key relationship, and this can be set up so that you can't put in a student that does not have a valid faculty ID. All right? It's not just a suggestion or anything like that. It's built right into the database. There's information built right into the database about this relationship. All right? What's more, you can make it so that I couldn't delete a faculty member if they were an advisor for students, right? You know, because that would sort of orphan that student. That student would be out there and without a corresponding faculty ID. All right? Or a corresponding faculty member for their ID. So you can prevent deletion and restrict deletion on a foreign key. You can also, and it isn't really relevant in this case, but you can also cascade delete. In other words, if I were to delete the faculty member, I could delete all the students that were advised by that faculty member. That's probably not a good idea in this particular case, because just because the faculty member retires or whatever is removed from the faculty table doesn't mean that you would go in and delete all the students. All right? Other cases, though, let's say you were a car rental company and you had automobiles and you had record of the automobile's maintenance. You know, that on June 1st they had an oil change, on August 1st they had a tire rotation, and so on. You might set up cascade delete in that case, because if you got rid of the car, you really don't care about the maintenance anymore. What do I care when a car that I don't have had an oil change last? All right? So in that case, you might want to set it up to cascade deletes. It's really a situational thing. The act of designing a database consists of making sure you've identified all the entities, identified the relationships, and identified the attributes and correctly associate them with the entity. Now, we'll talk about normalization rules in a minute, but the bottom line is this is what we're trying to achieve by our database design process and our normalization rules and all that stuff. This is what we're after. All right? Let me give you a for instance of how this could go wrong. All right? Of each of these, of how this could go wrong. Let's say in the student table, I didn't have a faculty table, but instead I had the faculty ID, the faculty first name, the faculty last name, and the faculty office. Now, the normalization rule would tell you that, well, the faculty office doesn't depend on the student ID, therefore it's in violation of the normalization rules. All right? However, an easy way to visualize that is you missed an entity. You're combining student and faculty information in one table. All right? Faculty members are different than students. And if I were to do this, I would duplicate information about the faculty members. And I would have redundant data, that's bad, leads to inaccuracies, inconsistency, and so on. So we could come to this conclusion either by looking and saying, hey, this violates the normalization rule, violates normalization rule number 3, for example, that says that no field should depend on something other than the primary key. In this case, these fields depend on the faculty ID. All right? Or we could just say, hey, you're combining two things into one. You didn't identify an entity. When you encounter this, what do? Well, you make an entity for the new stuff, and you keep the primary key of the entity and make it a foreign key to the new table. And so on. So you make sure you identify the entities. The other case where you don't identify the entities is if you have repeated fields. Let's say, for example, we reverse the situation. And let's say in each faculty, in the faculty table, we have a faculty ID, the faculty's first name, the faculty's last name, their office, and a list of the 4 courses that they teach. CISS243, or the class ID, the section number, the class name, and the number of credit hours. 1. Then would have for the second class they teach another set of class ID 2, class ID, or class section number 2, class name 2, and class or credit hours 2. And then we'd repeat that for however many classes a typical professor taught. Well, what's wrong with that scenario?
Same thing as before.
Yeah, well, one of the things wrong is, we're combining the data. We have course information in the faculty table.
And then repeating different, repetitive of the sections and names.
Yeah, and we're repeating fields as well. That's the second problem. So this has the first problem that I described, and it also has the second issue of repeating fields. And what's wrong with having repeating fields? do this then? Okay, let's eliminate that information. Let's put it in its own table. And let's have a class ID 1, class ID 2, and so on.
And that's getting repetitive?
Yeah, that's repetitive. I have class 1, 2, 3, 4, the IDs of the class. What's wrong with that? How many classes can a professor teach? I don't know, right? Depends on a lot of things, right? There are, for example, what's the one course, SDEV 101 or whatever. That's a 1 credit hour class. A teacher might teach a bunch of those, a bunch of sections of those. It means 1 hour a week, I think. All right? Maybe, I'm not really sure. But the bottom line is, if you're talking about a 1 credit hour class, a teacher might teach a bunch of them. If you're teaching 4 or 5 credit hour classes, a teacher probably won't teach as many. So it would be difficult to determine just how many classes that teacher taught. So therefore, another way of saying that is we've missed an entity. We've missed an entity that says that this class, this section, is being taught by this professor. So we've missed sort of a class section table that would link to the professor table. So again, the normalization rules would say that repeating fields are bad. And they are. And they're bad because you never know how many of them you should have. You know, I could put 10 of them in there, and there may be a teacher that's teaching 15 1 credit hour courses in a term. All right? It's possible. All right? In which case they wouldn't be able to enter that data into the database. All right. Again, the normalization rule would say you have repeating fields. The more conceptual way of saying it is you missed an entity. There's another entity there that you're combining with the faculty table. And you should break it out into its own entity.
So what would you break that into then?
You'd break into maybe like this, maybe a section table that maybe had the class ID as a primary key and the faculty ID as a foreign key. And then maybe the course number as an attribute.
And then in the faculty table, how would you would tie to class ID?
Well, no.
No?
The tying goes this way. From the faculty ID and table, or the faculty ID in the section table matches up with the faculty ID in that table.
Okay.
All right. Now, as far as identifying relationships go, there's really 3 kinds of relationships. All right? And the interesting thing is one of the relationships isn't real common. So we'll mention it, but we won't really dwell on it. The other 2 relationships are common, but the one of the other 2 relationships we can't implement in a database. And we have to change it into 2 of the other relationship. All right? Confused? Let's go over these one at a time, and hopefully that will clarify it. The relationship that you're going to implement in the database most often is called a one-to-many relationship. And on an ERD diagram, or entity relationship diagram, it would be represented like this. Let's go back to the faculty-student example. The crow's feet at the bottom indicate that one faculty member can advise multiple students, but each student is only advised by one faculty member. Sometimes on an ERD, they'll even write the verb, advises. Then there's all kinds of other symbols you can throw in, all right? That an O here means that, an O or 0, either way, it means that that relationship is optional. In other words, there may be faculty members that don't advise anyone. All right? That would indicate that it's mandatory for a student to have a faculty advisor, that they can't have no faculty advisor, that they have to have someone as their advisor. Whereas this would indicate that it's optional, that a student could have a faculty advisor, and if they do, they only have one faculty advisor, but a student may have no faculty advisor at all. So that symbol would indicate that a student has to have one and can only have one faculty advisor. A faculty member doesn't have to advise any students, but they can advise multiple students. Usually I don't worry about that quite so much, at least not at first. And I'll draw the one-to-many relationship like this and say that a faculty member advises many students. A student only has one faculty member that is their advisor. Now, here's the good news. Every one-to-many relationship you implement the same way. So once you learn how to do this, I can throw any one-to-many relationship in the world at you, and you'll know how to implement it. And the way that you implement it is that you say, I'm going to put in the many side of the equation, I'm going to put the primary key of the one side. And if you think about it, that makes sense, right? The primary key uniquely identifies. What's another way of saying uniquely identifies? It points to 1. So, if I have in here faculty ID, faculty first name, last name, and office, and in this table I have student ID as a primary key, student first name, student last name. All right. I would put as a foreign key in the student table the faculty ID. And I'll put the 2 asterisks indicating that that's a foreign key. So in other words, each student can point to the one faculty member that's their faculty advisor. When I make it a foreign key, it means I can't put in an invalid faculty ID in there. So if my faculty IDs are 1 through 50, let's say, I can't put in a faculty ID of 100 for a student, because that doesn't exist in the faculty table. So every time you have a one-to-many relationship, that's the way it's going to work. All right? If you think about it, it makes sense. One attribute in the student table can point to the one faculty member that advises them by using the primary key, right? The primary key is what we know uniquely identifies or points to one faculty member. If I tried to do it the other way, and this is kind of getting to your question where you said, how would I point from the faculty to the course? All right? You could ask that same question here. How do I point from the faculty to the student? If I tried to put the student ID here, what's wrong with that picture?
When they graduate.
Well, no. Simpler than that. How many student IDs could I put in this one field?
1.
1. That would mean that one faculty member could only advise one student. And that's clearly not what we define. We define the opposite, that a faculty member can advise many students.
Otherwise, you need the repeating field.
Otherwise, would need the repeating field, exactly. And would need student 1, student 2, student 3. And then the question is, how many students can they advise, blah, 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 repeating field. So, any one-to-many relationship will be accomplished this way. So this is mechanical. It's so mechanical, in fact, that a lot of the drawing tools, a lot of the tools that allow you to create ERDs, can actually create the database for you. Because it understands these rules, that if you have a one-to-many, that there's a foreign key from the many side to the one side. So if I look at this and I say, between department and faculty, there's a one-to-many relationship. All right? One department can have many faculty members, but a faculty member only works for one department. Right there, I know how to implement it, right? even without thinking about it, if I see that diagram, I know that there's going to be a department ID in the faculty table, or whatever the primary key is to the department table. There's going to be a foreign key that points to that, because the many side points to the one. With one column in the database, you can point to one thing. So, if I were to ask each one of you to point to the teacher in this class, you could all point with one finger, the index finger that is, who I was. All right? If you were to ask me the same question, point to all your students with one finger, with one column in the database, I couldn't do it. Right? I can't point to many. All right? You can point to one, however, and therefore the many side is going to always point to the one. So that's an example of a one-to-many relationship. And these pop up all the time. Another kind of relationship that you might have is a many-to-many relationship. Now, the key to identifying this correctly is making sure you look at it from both directions. Let's say we have a student table and a class table. All right? So, what's the relationship between student and class? To correctly identify this, we have to go both ways. We know there's a relationship between students and classes, right? Students are in classes, so there's some sort of relationship. One student can have how many classes?
Many.
Yeah, more than one, right? In database terms, you're really not interested in like the exact number. It's either one, none, or many. So if they can be a more than one, bang, that's many. A class can have how many students?
Many.
Can also have many students. So this is called a many-to-many relationship. All right? It's important, though, that you look at it both ways. You know, don't just look at it and say, well, let's see, a student could have many classes, so bang, that's a one-to-many relationship. Well, no, you haven't looked at the relationship going in the other direction. A class could have how many students?
So then you would put the foreign key in the student table from the class and the foreign key from the student table, or class into the student table and student into the
No.
class.
No. You can't do that. All right? Why can't you do that?
Because then you have a problem with repeated time.
Yeah, because let's imagine that. Let's put some names and some classes up here. All right? So, let's say we have a student, and let's say we have a student number 1 that's Joe, student number 2 that's Pete, student number 3 that's Mary, student number 4 is Sue. These names look like the names like in the kids' books that I used to read as a kid. John and Mary are taking, all right? And let's say the classes are this. And just to make it obvious, I'll make the class IDs in the hundreds. So class 100 is CISS243. Class 200 is CISS216. Class 300 is CISS 143. Let's say Joe takes CISS 143 and CISS 216. So, what do we put in the class ID as a foreign key here? 200 or 300? You really can't, right? You can only put one of them. So, class ID of 200, let's say. Well, we've just lost the fact that he takes CISS 143. Let's say that Pete and Joe take CISS 143. And that's the only class Pete takes. All right? So Pete takes CISS 143, and CISS 143 contains Pete. There's no way to show Joe as being in CISS 143, right? Because remember, with one field, with one finger, you can only point to one thing. So this student can only point to one class. The class can only point to one student. So there's no way to directly implement a many-to-many relationship in a relational database. All right? There's no way, so we're just going to give up and go home. All right. And are there any questions? No, I'm just kidding. There's no way, the key word in that sentence is there's no way to directly implement a many-to-many relationship. What do you do? Well, again, when you see a many-to-many relationship, that's a signal, let's say, that you're missing an entity. And that entity, you could call it a couple different things. I could call it the student class table, or I could call it the class roster table. But it's what's called as an intersecting table between the student and class table. So, just like mechanically, we can say that if there's a one-to-many, you put the foreign key in the many side and you point to the one side. In the case of a many-to-many, you break it down into an intersecting entity. So,
Like a translator.
I don't know. If you could view it that way. What this does is this matches up what students are taking what courses. I'll call this the class roster table. Sometimes you could give it a descriptive name that makes sense. Other times you just use the two table names. Now, what do we do? All right. We've transformed that many-to-many relationship into this. Now we have two one-to-many relationships. Well, we know how to do that, right? The many side points to the one. So, we'll have a student table that will have the student ID, the student's first name, student's last name, and maybe other stuff. We have the class table that has, a class ID, maybe the course number, maybe a section number, and other stuff. This class roster table or student class table, again, has to point to the student. So in this class roster table, we have to be able to point to a student, so we're going to have a student ID in here. And it has to point to the class. So we have a class ID in here. So the class ID is a foreign key that points to the class. The student ID points to the student. What becomes the primary key then is a combination of these two. With this, the water's slightly muddier than with the one-to-many because there's a couple of ways you can do this, but this is the first way that we'll do this particular example. This is the way we'll do this example, and we'll say the combination of those. So in other words, getting back to the example that I showed before, which I wish I didn't erase. If we have student 1, 2, 3, and 4, and student 1 is Joe, Pete, Mary, and Sue, and the classes are 100 is CISS243, 200 is CISS216, 300 is CISS143. Let's say Joe takes CISS143 and CISS216. In the class roster table then, we're going to store the student ID and the class ID. So Joe takes CISS143. Joe also takes CISS216. Pete, on the other hand,